In this video, I'm going to talk about two different methods for graphing linear equations. But first, I want to mention something that I noticed on your homework. So sometimes on your homework, we'll see equations that use this notation. This is called function notation. It is read as f of x. It does not mean f times x. It is simply another way of writing y. So we know that our linear equations have x and y variables. Most of the time it has both, sometimes just one of them. But whenever you see f of x, that means exactly the same thing as y. Okay, so if I had an equation that said f of x equals 2x plus 3, that means the exact same thing as y equals 2x plus 3. So you may ask, why do we even have this function notation? Well, it does a few things. One, it tells us if something's a function right away. Two, it gives the function a name. So if I have lots of different equations, such as y equals negative 4x plus 1, and y equals 3x minus 2, okay, I don't want to call them all y. So I could say g of x equals negative 4x plus 1. So now I can differentiate between function f and function g. So I know that these two lines are different lines. I don't have to always refer to them as, this is line y and y and y and y. Okay, so it gives the function a name. And lastly, it tells us what variable is the input and what's the output. So this is saying this is a function of f. So the input is x. Okay. The output is f of x. So I can put in a number into this function, like 3. I can plug in 3 for x, and 2 times 3 is 6. 6 plus 3 is 9. The output would be 9. So if I input 3, the output is 9. So it tells us what variable is the dependent variable and what variable is the independent variable. Okay, so we'll talk more about functions later, but I just wanted to mention this because I did see it on your homework. So, method 1 is all about making a table and plotting your points. So again, this f of x here means the exact same thing as y equals 2x plus 4. So I'm going to make a table. Oops, do not need to zoom in there. I'm going to make a table. I need to find x coordinates and y coordinates because we know that our linear equations are all going to be made up of ordered pairs that are solutions to this equation. So I can pick any value I want for x or y, but when it's written in this form, generally it's easiest to use the input, which in this case is x, and find the output, which is y. So I'm just going to pick some random values. So I'm going to pick something negative, I'm going to pick something easy like 0, 0 is always an easy number, and something positive. And now I have to find the y coordinates that go with this x coordinate. So I'm going to plug in first negative 2 for x. And then I can solve this or simplify it to find the y value. So 2 times negative 2 is negative 4 plus 4, which is 0. So that gives me the ordered pair negative 2, 0. Now I'm going to do the same thing with this next x coordinate. So now I'm going to let x be 0. So everywhere I see an x, I'm going to plug in 0. So 2 times 0 plus 4. Well, 2 times 0 is 0, so y must be 4. And last I'm going to do the same thing with 3. So everywhere I see an x, I'm going to plug in 3. So 2 times 3 is 6. plus my 4 gives me 10. Okay. So, in general, you only need 2 points to make a line. So as soon as I have 2 points, I can make a line, but we recommend that you find 3 so you can check your math. So if I'm supposed to be making a line, so a straight line, if I found something over here as my third point, I'd say, wait a second, this didn't work out right. This needs to be a straight line. And I go back and I check my math. I'm going to do one more because I don't think 310 is going to fit on my graph very well. I'm just going to pick 1 for x. So y equals 2 times 1 plus 4. 2 times 1 is 2, plus 4 gives me 6. Alright, so now I'm going to plot these points. So starting at the origin, I go -2 on the x-axis, and then I don't move up or down. Next, I'm going to start back at the origin. I'm not moving left or right, and I go up 4. I said this point's probably not going to fit on there very well, so I'm going to go ahead and skip that one. I'm going to go on to 1. So starting back at the origin, I'm going to go +1 and then up 6. 1, 2, 3, 4, 5, 6. And if I did this right, it should make a straight line, which that does look like a straight line. Now I'm drawing this freehand, so this probably isn't going to be the best line you've ever seen, but it should be a straight line. And when you draw your graphs for me on a test or something like that, I would very much appreciate it if you picked at least 3 points and labeled them, and make sure you're filling up the graph. Okay, I don't want to see any graphs that you've got this whole graph, you've got this itty bitty line, like that. Fill up the whole graph, okay? So if I were to label this, I would say this is -2, 0. This next point is 0, 4. And the next point is 1, 6. And that just makes it easier for me to grade. It makes me, or it helps me to understand what you were intending, things like that. Now, let's go on to another linear equation. So this one's not written in function notation, and that's fine. But I'm going to use the same method here. I'm going to use my table. So I'm going to pick some x values, find the y values. Now, this one has a nasty little fraction. I know a lot of you don't like fractions, but here's a tip to help you get nice numbers. Because when you're graphing this on the online homework, sometimes it's difficult and sometimes it doesn't let you graph things that are not nice points. So, if I have a fraction that I'm multiplying by x, and I want to get a whole number, remember what fractions do is this is dividing by 2 each time. Okay, this says 1 divided by 2. That's what a fraction is. So if I want to get a whole number, I have to have something that 2 will divide into evenly, or multiples of 2. So 2, 4, 6, 8, 10. And that works with any fraction. So if my fraction was 1/3, I would pick multiples of 3, because each time I'm dividing out a 3. So let's pick some nice numbers. I'm going to pick some positives and negatives. You don't have to every time. It just is kind of good graphing etiquette to fill up your graph. I'm going to pick -2, because that is a multiple of 2. I'm still going to pick 0. 0 times anything is 0. And a +2. Now I could also pick 4, 6, 8, anything like that. I'll get nice numbers. So starting at the beginning, I'm going to say -1/2 times -2 plus 3. A negative times a negative will be positive, and half of 2 is 1. 1 plus 3 is 4. So I get the coordinate -2, 4. Because that was my y that we just found. Same thing with 0. -1/2 times 0 plus 3. 0 times anything is 0. So y equals +3. Last, I'm going to plug in +2. Negative 1/2 times a positive 2 plus 3. Now, a negative times a positive will end up negative, and half of 2 is 1. Negative 1 plus 3 is a positive 2. I've got 3 points, I'm going to go plot them. So starting at the origin, negative 2, positive 4. 1, 2, 3, 4. Back at the origin, 0. I'm not moving left or right. Up 3. 1, 2, 3. And back at the origin, positive 2 on the x-axis, positive 2 on the y, or the vertical direction. That looks like a straight line, so I'm going to go ahead and extend it out. Again, doing this freehand. Helps if you have a ruler or straight edge of some sort. And again, I've extended it across the whole graph. And then for me, I love it if you label your points. There you go. So that is method 1, using a table to graph linear equations.